Okay, hello everybody, and this will be Geometry, section 10.4. Today we're going to talk about and look at inscribed angles and 4 important properties about inscribed angles that we can use to solve even more problems with circles and angles. All right, first let's look at and review a property from earlier in the chapter. Remember that a central angle comes out of the center point. So this would be a central angle. And remember that whatever the degree measure of the central angle is, that is also the degree measure of the arc. So if this is a 40-degree central angle, then the arc has a 40-degree measure. Now, inscribed angles are different. We're going to talk about them next. An inscribed angle, think about inscribed, the word means drawn on the inside. So again, it's an angle that's drawn on the inside, but the important thing is that not just any angle on the inside, the important thing is that the vertex is on the circle. So an inscribed angle is an angle like this, where the vertex is on the circle. Okay, so let's look at this inscribed angle here. This is the center point. Every inscribed angle has what we call an intercepted arc. And that would be this arc NS right here for this inscribed angle I. So basically the intercepted arc simply is the arc that is opposite the inscribed angle. You have two sides of the angle that hit at points in an S. The arc between them on the interior of the angle is the intercepted arc. Now, central angles also have an intercepted arc. So even if you have a central angle, this would be the intercepted arc. And if you have an inscribed, this would be the intercepted arc for this one. Okay? Now, get used to seeing inscribed angles that look a little bit different. Here you have an inscribed angle where the center point is on the interior of the angle. But you could also have an inscribed angle like this, where the center point is on the exterior. So see how this inscribed angle is all shoved over onto one half of the circle, but it's still an inscribed angle. And you could also have an inscribed angle where the center point is actually on one of the sides of the angle. This would be the diameter. But this angle right here is still an inscribed angle. And this would be the intercepted arc. And here, this would be the intercepted arc. Okay, so inscribed angles might look a little bit different, like any of these. All right, first property concerning inscribed angles. First, the inscribed angle is half of the intercepted arc. This is different than central angles. Central angles are the same measure as the intercepted arc, but inscribed angles are half. So let's say that this is a 124-degree arc. Inscribed angle is half of that, 62. And vice versa. If you know the intercepted arc, you double it to get if you know the inscribed angle, you double it to get the intercepted arc. So let's write that property down. The inscribed angle is 1/2 of its intercepted arc. Guys and gals, a lot of people confuse and mix up and forget these two very important properties. A lot of them think these are the same for an inscribed. No, it's a 1/2 or times 2 relationship. Central angle same. Okay, so don't get these mixed up or confused. Keep them separate. All right, let's look at second property. And a lot of these properties are pretty straightforward, but we'll go through all of them. And we'll use them to solve some problems on the back. Or on side 2 of the notes, rather. All right, let's look at the illustration or diagram for number 2. Here we have an angle R inscribed and an angle B inscribed. Now, if you look at each of these intercepted arcs, here's angle R, inscribed angle, and the intercepted arc is right here. Well, if you look at if you look at inscribed, I'm getting inscribed and intercepted confused, sorry about that. If you look at inscribed angle B, right here, it has the same intercepted arc. So that means you know that these two angles, R and B, have to be congruent. Because if they have the same degree measure intercepted arc, you chop that in half, you're going to get the same degree measure for each angle. So you would know that these are congruent. Angle R congruent to angle B. Okay? Because they share an intercepted, I'm going to abbreviate a little bit, they share an intercepted arc. So two inscribed angles are congruent if they share an intercepted arc. And let's look at the third property real quick on side 1. And we kind of touched on this in an example earlier in the chapter. Okay, here you have a triangle inscribed in the circle. And this is a diameter. Now, we're going to focus on angle T right here. Angle T is obviously an inscribed angle. If you look at the intercepted arc, it goes from Y all the way to R. And since this is a diameter, that means it's half the circle, 180 degrees. Half of 180 is, correct, 90, which means inscribed angle T has to be 90 degrees or a right angle. Okay, so if you guys ever have an inscribed angle and the intercepted arc is a semicircle, or you have the diameter here, it's got to be a right angle. Okay, so 180 degree intercepted arc means that's a right angle, 90 degrees. So angle T is 90 degrees or a right angle because the intercepted arc is a semicircle, which is 180 and half of that 90, so angle T is a right angle. So look guys, basically if you ever have a triangle inscribed in the circle and one of those sides is the diameter, like this, you know it's a right triangle. Right angle, because this means it chops it in half, 180, half of 180 is 90 for that angle. All right, let's go to side 2, or the back side on mine. We're going to look at the fourth property, and then we're going to do some problems. Okay, on this property, what we have is a quadrilateral that's inscribed in the circle, an inscribed quadrilateral. And we have 4 angles, and all of these are inscribed angles because the vertices are all on the circle. Now, just for terminology, because you might see or use or read this in this section, an inscribed quadrilateral can also be known as or called a cyclic quadrilateral. These are just synonyms. You might see it described as being this or this. A cyclic or cyclic, I don't know how you pronounce it, probably cyclic. So an inscribed quadrilateral, same as a cyclic quadrilateral. Inscribed in the circle, all inscribed angles, vertices on the circle. All right, the property here for any inscribed or cyclic quadrilateral is that the opposite angles are always supplementary. And remember, that means that their total or sum is 180 degrees. Now the opposite angles, guys, not the consecutive angles. Not 2 and 3 or 3 and 4, but the opposite angles. So like 1 and 3 add up to 180. 2 and 4 add up to 180. Okay? There's really no relationship between consecutive angles like 1 and 2 or 2 and 3 or 3 and 4, unless you know what type of quadrilateral it is. But this is always the case for opposite angles in an inscribed or cyclic quadrilateral. So angle 1 plus angle 3, you know, would total 180. Same with angles 2 and 4, because they are another opposite angle pair. All right, let's move on to problems 1 and 4 below. These are going to be similar to several of your homework problems. All right, number 1, we got to get the angle measures of 1, 2, and 3 right here in this triangle. And we're given a few arc measures, 56, 64. Now, let's look at angle 1 first. Angle 1, if we look at the intercepted arc, it's an inscribed angle. The intercepted arc is right here at 56. So half of 56 would be the inscribed angle measure for angle 1. So 56 divided by 2 would be 28 degrees, measure of angle 1. If we look at angle 2 next, right here, this is an inscribed angle. If we look at its intercepted arc, which is over here, 64 degrees. Half of that would be the measure of angle 2, which would be what, 32? Now look, guys, if you're in this triangle here, you know 2 of the angles. Just simply subtract from 180 to get angle 3. So 180 minus these 2 will give you angle 3. And that comes out to be 120 degrees. Okay? Let's look at angle or problem number 2 next. All right, problem number 2. We have a triangle inscribed in the circle. This is a diameter. Okay, so angle 1, we need the measure of it. Correct, this is a right angle. So it's 90 degrees. Because that's from property 3 on the other side of the notes. All right, angle 2 is easy to get now. 90 and 50 from 180 leaves you 40. So 180 minus 90 and minus the 50 you have, 40 degrees. All right, now we need to get a couple arc measures. First, arc AC, right here. Well, if we look at its inscribed angle, this is the intercepted arc for this inscribed 40-degree angle. So if we double it up, we should get an 80-degree arc. And XC, arc XC next, which is right here. Its inscribed is 50. So if we double this up to get the arc, 50 times 2 is 100. All right, so 100 degrees for arc XC, number 2. All right, let's move on to number 3. All right, we want to find the measure of angle T, which is right here. And if we look, this will be using property 2 from the other side of the notes. The intercepted arc for angles T and R is right here. They share this intercepted arc, so that means T and R are congruent or equal, so we can simply set them equal and solve for x. So 6x plus 18. Set it equal to 4x plus 24. A little bit of algebra here. Subtract 4x to get 2x. Subtract 18 to get 24. And x comes out to be, to get 6. and x should come out to be 3. Now we want the measure of angle T. So we plug 3 back in for x, substitute it in for x. 6 times 3 is 18, plus 18, 36 degrees for angle T there. All right, and moving on to the last problem. It wants us to find angle E. All right, angle E is right here. 4m plus 10 is the expression we get. And if we look at its opposite angle, we're given an expression for this opposite angle. And from the property above, property 4, opposite angles in a cyclic or inscribed quadrilateral are supplementary. So we know that these two total 180. All right, so we can just simply add them together, the 4m plus 10 angle, add it to the 2m plus 20 angle, equals 180 total. That's 6m plus 30 when you combine like terms. A little bit of algebra. Subtract 30 to get 150. Divide by 6 and m is 25. Now we want angle E, so we plug it back into this expression. 4 times 25 plus 10. 100 plus 10 equals 110 degrees for angle E. And there you have it, guys. That is section 10.4, inscribed angles, a very important topic and concept in geometry and when we're dealing with circles. Until next time, you guys take care and stay healthy. Bye-bye.